don't you? Oops, the random penguin just fell off my head. Okay, ready? We are doing applying parallel lines to polygons. I'm so excited because today we're going to be talking about a triangle. And what's a triangle? Put these all in your notes. If you open to page 72, there's a bunch of different triangles. 1, 2, 3, 4, 5, 6, 7. There are 7 different triangles. You're going to draw them all in your notes. You're going to draw the definition, write the definition of a triangle. A figure formed by 3 segments joining 3 non-collinear points. So here you go. Here's our figure. It's got 3 segments. They're non-collinear. All 3 are non. If we had them 3 in a line, they would be collinear. These are not in a line, the 3 of them, so they're non-collinear. Of course, I have triangle JOY because Joy knows how much I love her name. These angles right here are called the vertices. That's plural for vertex. This is your vertex, this is your vertex, and this is your vertex. A vertex is the points of the triangle, and the sides of the triangle are obviously segment OY, segment JY, and segment JO. And the angles of this triangle would be angle J, angle O, and angle Y. And of course, you know, we could call that angle JOY, angle OYJ, or angle YJO. Okay? All right, so let's talk about different types of triangles. I love this stuff. A scalene triangle, say the word scalene, draw this in your notebook, has no sides congruent. Okay? I'm not the best drawer, we all know that, but no sides congruent. An isosceles is a funny spelling. At least 2 sides are congruent. So you have these 2 little hashtag markies in your triangle. So this would be an isosceles triangle. An equilateral, all sides are congruent. Cool, huh? An acute triangle is all angles are acute. This is just barely acute, but it is. An obtuse triangle is one obtuse angle. So this is your obtuse angle. It's just a little bit over 90 degrees. At least I tried to get it a little over 90 degrees. Right triangle, you're going to always notice the little box in the corner. That's a right angle. And then an equiangular triangle. All of these are equal, and we're going to find out something really cool about triangles, and especially like equiangular, equilateral. All the angles are congruent. Okay, so if you flip over to page 73, you're going to see the word auxiliary line. Auxiliary line is a line, ray, or segment added to a diagram to help in a proof. They give you a proof on page 73. They had a triangle, and they drew this little fake line. And the reason why they drew it is because they wanted to prove Theorem 211, which you're writing in your notebook. It says the sum of the measures of the angles of a triangle is 180. Okay, the proof for that is there, but now you know that the sum of the measures of a triangle is 180. So if you add angle 1, 2, and 3 in any triangle, no matter what it is, all these triangles, they're always going to equal 180. Isn't that cool? So over here in our, oh, it's over there. Sorry. No, where is it? Where did I draw it? Oh, the equiangular triangle. Here it is. Sorry. If you know that all of these add up to 180 and all the angles are the same, if we divide 180 by 3, you're going to get 60. So in an equiangular triangle, all the angles are 60 degrees. Isn't that cool? Okay. You're also going to learn about corollaries, and corollaries are statements that can be proved easily by applying a theorem. Okay, so you want to write that definition in your notebook. A corollary is a statement that can be proved easily by applying a theorem. You can use corollaries as reasons in a proof. I know somebody even already noticed that, and they were like, oh, more reasons for proof. But corollary 1, write this down in your notebook, page 73. If 2 angles of one triangle are congruent to 2 angles of another triangle, then the third angle is congruent. So if you have 2 triangles, okay, and you know this one is congruent to this one, and you know this one is congruent to this one, well, we know that they all equal 180, so if you add them up, this one is going to come out to be congruent to this one. That's corollary 1. Corollary 2, each angle of an equiangular triangle has a measure of 60 degrees. I already showed you that. Corollary 3, in a triangle there can be at most one right angle or obtuse angle. Obviously, if that's 90 degrees, the other two angles are going to have to equal 90 degrees. So there's no way, I can't even begin, if I draw two right angles, that automatically does not make a triangle anymore. So you can't have two 90-degree angles or two obtuse angles, because an obtuse angle is any angle over 90 degrees, so that's not going to work. So there's only one right angle, one obtuse angle in a triangle. Corollary 4, the acute angles of a right angle are complementary. So the acute angles, obviously, okay? If this is 90 degrees, these two angles have to add up to 90 degrees because the whole triangle is going to be 180. So they will be complementary. Only in a right triangle, though. Don't get confused because that's only a right triangle. Let's move over here and talk about exterior angles, okay? Exterior angles are the angles that are on the outside of the triangle. So here's your triangle. In this angle right here, and we could draw another one right here. We could draw another one right here. This angle is going to add up to these are remote angles. So let's see, if that was 80, that would be 100. Well look, 70 plus 30 equals 100. So, okay, you got that? That's the exterior angle. It's going to add up to the remote angles. Let's figure out what this angle would be. If that was 70, 180 minus 70 is 110. Let's see, does 80 and 30 equal 110? Yes, it does. How about this angle? If that's 30, that would be 150. Does 80 and 70 equal 150? Yes, this exterior angle adds up to these two remote angles. Down here is another example. This angle is an obtuse angle, it's 115. So we know 180 minus 115 is 65. Let's see, does these two angles add up to 65? 40 plus 25 is 65. Okay, if we drew another line over here, right into my, my light switch, 180 minus 25 is what? 155, right? Okay, 155 is this light switch angle, okay? So 155, does 114 and 40, can I speak? No. 115 and 40 add up to 155? Yes, it does. All right. So I would like you also to put the proof on page 73 for Theorem 211 in your notebook, okay? There is an example on page 74, number 1. If P is congruent to V, it says, is P congruent to V? So look at that example. Look at where P and V are. So R is congruent to E, that's given in the diagram. Angle 1 and angle 2 are vertical angles. Thus, P is congruent to V by corollary 1. Okay, so that's something that you can look at. You are going to do the classroom exercises. Go do them right now. And I will put up the answers later. On page 74 and 75, you're doing classroom exercises 1 through 21. Have fun. Keyword is penguin. I can walk like a penguin. See ya.